Hello, welcome again to a Swift review. Today we're talking about optionals. What are optionals? Optionals is a type in Swift that says there could exist a value or not on an object. So let's go ahead and start visiting what optionals are. So we'll create a dictionary here. This dictionary will be of type string and string, just like this. And this is where we are. So what does force unwrapping mean? If I want to go ahead and say access, let's actually populate this dictionary here. We'll say dictionary at, for example, my name here, and I'll say last name is Paul. So first name, last name. And I could go ahead and use force unwrapping by saying first name, or rather last name equal to dictionary at Alex, just like that. And I could use an exclamation mark here because if I try to print, say last name like this, last name will say it's an optional Paul. If I don't want to have this optional Paul printed out, I could force unwrap it by putting this exclamation mark here. It's no longer optional. I could print and it says Paul. But the problem comes in if we want to say Erder last name like that, and we access some key, for example, Sarah, like that, that doesn't exist. So this is the problem here with force unwrapping. Force unwrapping saying, I'm the developer. I know there's a value. I'm going to use an exclamation mark to get out that value from the optional. But as we saw here, it could be very dangerous because if there's no value for Sarah, our app will crash. So be very careful with using force unwrapping. Other ways we could unwrap safer, we'll see as we keep going. So next we want to talk about implicit optionals. What are implicit optionals? If I have name, for example, here, and I could say it's a string, and I could use exclamation mark here, which is implicitly unwrapping it. This is not force unwrapping here. This is just implicitly unwrapping, saying at some future time, this is already unwrapped, so no need to unwrap it again. So what are we gonna do with this? We'll say let unwrap name, for example. Unwrapped name is a string, and here we will pass it name. So here, if I print, before we print name, actually, let's go ahead and see. So this is a constant here. Let us make sure constant name used before being initialized. So here we can't do this. This has not been initialized yet. So the compiler will let us know. This is fine because we haven't initialized this yet. So now we want to go ahead and assign it to unwrap name. If I option click here, it's a string. It's no longer string optional. But if I was to use a question mark here, like that, the compiler will say we need to unwrap it before we assign it to the string. So this is one of the ways where you could use implicit unwrapping to avoid you from unwrapping again in order for you to assign it to some value. So here, this is implicit unwrapping, but we need to make sure we have a value here before we assign it. So here I could just say Bob, like that. And now I could print unwrap name, and I would get Bob. Okay, because again, this is implicit unwrapping. No need to unwrap it again because it's already unwrapped. It has a value, and we were able to print it out. If we make it this a question mark, the compiler will tell us, hey, you need to unwrap this first before you assign it to a defined string. This string is not optional. It's expected. This is why we type annotated it explicitly. This is some of the places where you have to type annotate explicitly. This is one of the use cases. So if you implicitly unwrap here, now I could assign name, and this is good. One way to unwrap, this is very, very popular, is what's known as Nil Coalescent. So as we had earlier, we got a crash when we first unwrapped Sarah that did not exist. So we could actually grab this code and bring it down here and see how we could do this safer. So instead of using an exclamation mark here, which is going to crash our app, as we saw earlier, right? We could use Nil Coalescent. What does that look like? So it's two question marks and a default value. In that case, we expect our value to be a string. So whatever the default value here is, it needs to be a string. And in that case, I could say, let's just default to no name, nameless. And if there's no value found for Sarah, it will default to nameless. So let's go ahead and print other last name. And here we'll see nameless because Sarah does not have a value, so it defaults to nameless. Great. Other ways we could unwrap is what's known as optional binding. Basically, you unwrap a value, you bind it to a constant or variable, and now you have access to it. So you'll see if let, or you'll also see if var. Again, let is a constant, var is a variable. You could mutate it. So we'll have our optional binding here. Let's go ahead and create some sort of, we have values already. Actually, we have our dictionary object. So let's use that. We have our dictionary here. It has Alex for now. So now let's go ahead and retrieve the last name. So we'll say, we'll use optional binding. We'll say if let last name. So last name here represents our constant. We just give it a name. And we will go ahead and use our optional on the right side of this equation. So here we will say optional dictionary, and the key is Alex. And here we have our bracket. So how does this read? Basically, this is an optional. If this optional does have a value, assign it to last name. And now we could just go ahead and print last name. So this is called optional binding. It binds the value it finds to last name. Again, if there's no value for Alex, nothing will happen on line 29. In that case, we'll go to, if we have an else statement, we could print no last name, for example, no last name found, like that. But for now, we do have a value because Alex has a value. So if I go ahead and run this code, I will see Paul printed out. If it was Sarah, for example, we would get no last name found. So this is optional binding. Again, it binds the value it finds to last name, and now we have access to last name. If let is very popular. Again, this could be a var. For example, if you want to change last name for some reason, you could say var, and now I could assign last name to some other value, like Appleseed. And now if I run my code again, instead of last name being Paul, it would be Appleseed. But we clearly see this does not exactly add up to what we're trying to find, because we're just trying to find the last name, not exactly change the last name. So we'll say let here. And now we'll get a compiler error because this is a constant. We can't change the last name. So default will be if let, unless you want to change the variable, then you'll make a var. But normally it would be if let, you bind it to whatever name you want, constant name you want, and that's it. Next, we'll go to the guard let, which is also very popular. Guards only work in functions here. So we'll create a function. We will call this function, for example, print name. And print name, we'll take in some string or some string, which is an optional string. And this optional string will use our guardlet, because remember, we are trying to unwrap this optional. Okay, so we'll unwrap this optional using a guard statement. And the way we'll do it, again, there's also guard var. right? If you want to change the, if you want to mutate the variable, you do guard var. So here we will say guard let name, like that, or guard let name string, and we'll say string here. And the guard comes with an else statement. So here you say else return. So this is the syntax. Guard let, again, could be a guard var if you want to mutate name string. And what you want to unwrap is always on the right side of the equal sign. In that case, the string is the optional. This has to be an optional. I can't just put in any sort of variable here that's not an optional. It's required to be an optional because you're about to unwrap it here. So, and there's an else here. So it's a guardlet followed by an else. Okay. And the else, this block else here will exit the function. So if my string is nil, it will just return. Okay. So this will exit the function. Exit the function. But if the name, if string does have a value, then we'll have access to the value after our closing bracket here. So now we'll have access to the value here. Then I could print, actually, let's just change this. So print message. I think this is better. And then here we'll just have message. And here we'll have message. And here we'll have message retrieved. And I'll be able to just print message retrieved here, just like that. And how do we use our function? Well, we use our function like this. We'll just say print, actually not print, we'll just call print message. And we'll pass in hello Swift, like that. I'll run my playgrounds and it will say hello Swift because we did pass in a message. But if we pass in nil, which we can, why can we pass in nil? Because this expects an optional string. So it could be a string or nil. So here we could totally pass in nil, just like that. And if I run my code again, nothing will get printed. So here I could actually put a message saying print no message received. Okay, so if I run my code again, here I'll see no message received. Okay, because what happens then, I come into my function, I use my guard statement, message is nil, it doesn't go to the print statement. Instead, it goes to the else statement. In other words, it's false. So if it's false, meaning it's nil, then it comes to this else statement, it prints no message received, it returns, which exits the function, never gets to line 40. Okay, so this here is optional binding using guard let or guard var. If you want to change it, you would change it to guard var. Next, we'll go into what's known as optional binding on a while let. So while let is a loop, or it allows us to loop. So here we'll actually, this is very popular when you deal with abstract data structures. So abstract data structures, while lets are very popular. So if we were to create a class here called node, and node has a value, node has a value which is an integer, and node has a next pointer which is a node, and here we'll have some initializer which takes in some value which is some integer. And here we could say self.value. We'll come to classes later. And then value here. And now, say we create some nodes. So we'll have node 1 is some node that has a value 1. and we'll create two more nodes. So we'll have node 2, node 3, and here we'll have node 2 and node 3. And now we were told to write some function. Actually, let's connect our nodes together. So we'll say node 1.next is pointing to node 2, and we'll say node 2.next is pointing to node 3. So what do we have here visually? Looks like this. So we have some object that has a value 1 pointing to a next object with some value 2 pointing to some next object pointing to 3. And the last object is pointing to nil. So question is, how do you iterate through this data structure? Well, we can't use a for loop, right? Because we say for node in node 1, for example, like that. And we say print node. If we say print node like that, and we run our code, we get a compiler error. For loop requires node to conform to sequence. Node currently does not conform to sequence. How else can we make this work? Well, we could write a function that says print nodes, just like that, that takes in some node, or we could do everything in line, actually, but doesn't really matter. Let's actually just do everything in line. So here, let's just write a function, that's fine. So here we write a function that takes a node. The node is going to be optional because here it could be optional. And then we'll go ahead and we'll say while, coming down to how to use the while let. So while let current node, again, we're unwrapping. Node needs to be an optional. This is why we made node optional here. So what are we doing? We're using while let right now, optional binding. So while there is a node, in other words, while node, right, has a node, keep going. So what do we want to do? We'll print current node dot value, just like that. And in a while loop, we need to go to the next node. So currently I'm at node 1, I want to get to node 2. How do I get to node 2? I get to node 2 by assigning node current node dot next, just like that. So now I'm able to walk the nodes. So now I can't mutate node. How do I fix this? Well, we'll just make a var node equal to node. Basically, we shadowed the variable, and now we're able to mutate the variable. So this is what a while let looks like. Very powerful. So let's just go over this. So the node is an optional. If I option click, it's an optional. Unwrap the optional, bind it to this current node constant, print out the value, go to the next node using the current node object. And now I have my node here. I assign it to node. Again, node is an optional. So it will keep going until node is nil. When node is nil, it exits the while loop. So when node is nil, exits the while let. Again, we have while let, but you could easily make this while var if you want to, again, mutate current node. So this is while let. Again, very powerful when it comes to abstract data structures. But for basic Swift language concepts, you might not come across while let very often. But when it comes to abstract data structures, the while let is very, very, very useful and very powerful. Lastly, we'll talk about optional chaining, and let's see what that looks like. So that comes in very handy when you tend to do, for example, password email verification, password, not verification, but more like you have two text fields. So assuming you have two text fields in an application, right? So two text fields in an application. One of those text fields is the username, and the other one is, say, password, right? So before you go ahead and try to authenticate the user, you want to make sure that those two text fields have values in them. So how can we do that? We could do that with what's known as optional chaining. So one optional unwrap followed by a next optional unwrap followed by a next optional unwrap, and so on and so forth. So here, let's go ahead and create two variables. So we'll say var, or they could actually be, let's make them variables. So we have username, which is an optional, and we have password, which is an optional. And why are those optionals? Because for now, I'm trying to illustrate what text fields are. So a text field, text value is optional. Okay. Text field.text, we'll come to that when we talk about iOS specific, but this is optional string. So what we want to basically illustrate what that looks like. So if we have a username, it's optional, a password is optional. So if, let's just go through the scenarios of unwrapping it. So basically we want to unwrap those two values. We'll use optional binding here. I'll say if username, we could actually use the same name. But for now, let's just not use the same name. We'll say username exist equal to username, comma, that's how we chain them together, comma, let password exist equal to password, followed by open curly, close curly. So at this point, what happens? Let's talk about this code. In order for us to actually print, let's actually print user entered both values, right? Else, if the user did not enter one of those values, it will come to the else statement. So both those values need to exist in order for us to actually print user entered both values. Else, print user is missing fields, like that. If we run the code, here, we'll see the message user is missing fields because both of them are empty, right? Now let's actually go ahead and for username, let's put in Alex Paul, just like that. And let's run it again. Same thing, user is missing fields because username got unwrapped. It does have a value, but password is still missing a value. So if we put password here, it's a string, could have made it an int, but it's okay. They'll enter it as a string. So this is our password. And if we run our code again, this time user entered both values, okay? We're getting those warnings because we're not using the values here. We could actually just use string interpolation for this and say user entered both values, and we could just interpolate both values just like that. And here we'll say user exists, and here we'll say password exists. So get rid of those warnings and run our code again. And we will see user entered both values. We have Alex Paul, which is no longer an optional. It got unwrapped, user exists. And we have the password here, which is again unwrapped. Okay. So this is taking a look at optional chaining along with optional binding. So very powerful, very powerful. Optionals are great in the Swift language, allows us to do a lot of safe coding in our projects. So again, thank you for watching. Do like the video, to subscribe. Thank you very much. See you again.